Hello guys and welcome to DTW Tutorials. Welcome. So in today's video, I'm going to be solving 15 past questions on AC circuits, okay? Because I've received a lot of, I asked the question, what are your difficult topics? All right, and most people were saying AC circuits in physics. So I'm going to be solving 15 questions, past questions. I've gotten a lot of them, okay? So you can see we have a lot here. Hold on, let me just show you this. Okay, so you can see them here. So we're going to be solving 15 of them. All right, so just sit back and relax. Make sure you watch the video to the end because as I'm solving them, I'm going through each aspect of the topic AC circuit. Okay, so I'll be as I'm explaining, as I'm solving the question, I'm explaining some particular terms in AC circuit, your RMS, your impedance, your resonance, everything. So I've gone through past questions from, I think, from 2001 downwards. Okay, so and I've gotten all those AC circuits, and I noticed that in each Jamb exam, you get at least one AC circuit question. So with all these questions I'm going to solve for you today to help you understand, I'm sure you will be able to get that question when you come through it. So sometimes you get, in some particular year, there will be two questions from AC circuit, that's alternating current circuit, or there will be one. There must be a question from alternating current circuit. Okay, so make sure you watch this video to the end, and please share this video, please, to all science students. That every science student is going to take physics. That's, whether you're going for medicine, you're going for engineering, you're going to take physics, okay, or any sciences, you're going to take physics. So please share on your Facebook groups, on WhatsApp, share with your friends in your tutorial centers, share to help them in passing their exams. And don't forget to subscribe to our YouTube channel. Okay, subscribe for, we do free videos on maths, physics, and chemistry. There's a playlist. I'm going to leave the playlist in the video description box of every resources, okay, that you need. All right, your physics past questions solved, your chemistry past questions solved, over several 1,000 past questions solved on the DTW Tutorials channel. Also get a CBT app. Okay, DTW, we have a CBT app for your Jamb, also for your WAEC. I'll leave all the link. Get it, activate it. It's 2,000 naira. So this is an investment into your future, into your exam. So get it to practice, because you need to be in that practice mode. Time yourself, get familiar with the CBT interface. I've also done a video of how to use the computer during the exam. If it's your first time and you didn't register for your mock, okay, so I've done a video on how to use the computer during your CBT exam. I'll leave all those links in the video description box of this video. You can also check out our website for summary notes on physics and chemistry. You're going to see all this. So there are several resources, by God's grace, have been preparing for you for free. Okay, so please check out all these resources that would help you pass your exams. You can also join our Facebook group also for information. I always post a lot of information on the Facebook. You can join the group for constant information on your exams. All right, so I think, is that all? Yes, and I will leave all the links in the video, just in the video description box. I'm going to leave all the links. Okay, and I also want to introduce, there's a YouTube channel called DCW Tutorials Junior for your siblings. Okay, that's where you get there are free videos for common entrance, for junior WAEC, for them. If you have siblings around you preparing, younger ones preparing for all those exams, there are free videos that would also support them, just like this. Okay, so is that all? All right, so finally, one more thing I will go before say before we get into solving all these questions is, please do give your life to Christ. Okay, Jesus is coming very soon. He is coming. All right, and the only way to God is through Christ. There's no other way. All right, it's only through Christ. It's the way, the truth, and the life. All right, and it's calling you today to give your life to Christ. What it simply means is, receiving Jesus, accepting him as your personal Lord and Savior, and repenting from all your, your evil way, any evil ways or you've indulged in, just repent and come into him, renounce all those things and walk in righteousness with Christ Jesus and holiness, and he will make everything whole in your life. Everything whole is going to make it and give you that heaven on earth here, and also take you to heaven at last, which is eternity, where we're going to spend our life after death. Okay, so thank you for listening. So now let's get on to solving all these questions here. Now the first question here says, in the diagram below, determine the RMS current. Now, what RMS means is root mean square current. So we have two things in AC circuit. There's root mean square current and there's root mean square voltage. Okay, your RMS is equal to the peak current over the square root of what? 2. Okay, this is the formula for the current, root mean square current. Why? The root mean square voltage, that's Vrms, is equal to IP over the square root of 2. And when they mean root mean square, they mean the effective value of current in this circuit. When they mean voltage, it means the effective value of current in this circuit. Now, peak means the highest it can go. Now, in Nigeria, the effective voltage we use is 240 volts, while the peak is 340 volts. Okay, so there's a difference between RMS. The values are different. Okay, there's a difference between RMS and what peak. When you say IP, it means the peak, the maximum current. Oh, sorry, this should be V. Okay, the maximum current and the maximum what voltage. All right, that's for an AC circuit. Sinusoidal circuit that you see this particular symbol. Okay, it's not like the DC that is just constant. It's a straight line. All right, for AC circuits, the current would go back and front, while DC, just a straight line, it flows. Okay, so now in this question now, it says determine the RMS current of this particular circuit. So from here, we are given the inductance, the inductance or reactance here for the inductor. Okay, and here we are given also a resistor and 240 as the volts, RMS volts, and we're told to find the RMS volts current. So to do this, we have to first find the impedance. Now, impedance Z is the total resistance plus reactance. All right, reactance means reactance in the inductor and also the capacitor. All right, then resistance is the resistor here, the total resistance. That's if you had like two resistors here, you have to do the total resistance to get it. So impedance is the summation of your resistance and what your reactance. Okay, so we now have to find the impedance of this circuit, and from impedance is what? Our V. Remember, V is equal to what? Ohm's law. V is equal to IR, and the unit of impedance is what? Ohms. Okay, so we're looking for what? The R. So R is what? V over what? I. Okay, so impedance will be what? V over I, and it is VRMS over IRMS. That's effective value of the voltage over the effective value of what? The current. That's our what? Z. So we have to first get our impedance of this particular inductive circuit, then before we can now get our I. Okay, so we are already given V RMS, which is what? 240 volts. So first of all, let's find the impedance of this circuit. So for impedance of an inductive circuit, Z is equal to what? The square root of what? Our resistance square plus what? The what? Inductance. All right, square. So here we have here R square, that's 4, that we have 4 square plus XL is what? 3 square. Okay, so here this is 8 plus what? Sorry, this is not 8, this is 16. 16 squared plus what? 9. All right, so, and what would this give us? This will give us what? 25. And the square root of 25 will give us what? 5. So we've gotten Z as what? 5. Is that not it? Okay, so the next thing we have to now get is um our value for what? IRMS. Okay, so Z is equal to VRMS over IRMS. This is going to be a long video, so stay tight, okay, because we have 15 questions to go. Okay, but I'm going to be a bit fast, but not too fast, so I stay balanced between different learners. Okay, so Z is 5, and this is what? 240 volts, and we're looking for I. So we just, subject of the formula, I comes here. So we have 240 divided by 5. And what would that give us? That will give us what? 48. For all this, in Jamb, you should always, when you're practicing, we should always practice without a calculator. It's going to help us be fast. But for all these particular, operations, or yeah, and division operation, there's the small calculator that is not scientific, which you can quickly bring up on your screen, on your CBT screen. I've showed in that video of how to use your computer, I've showed how you can go there, click, and do your calculations, okay? Just in case, for speed for you, okay? If you don't remember how to, you can always go there to help you out, okay? That calculator is not scientific, it just does normal simple basic arithmetic, okay? So the answer for this is 48. Sorry, not ohms. Okay, this is current, so current is what? Ampere. Okay, so 48 amperes, and our right option here is option C. Okay, all right, so let's get on to the next question here. Okay, this question is quite long. Okay, so that's XL. I've not been pronouncing it right. Inductive reactance. Okay, so for this one now, it says a capacitor of 20 times 10 minus 12 farads and an inductor are joined in series. Okay, so a capacitor, inductor joined in series. Okay, the value of the inductance that would give the circuit a resonant frequency of 20 kilohertz is, okay, now this takes us to a term called resonance frequency. In resonance frequency, it is when the inductive, okay, reactance is equal to the capacitive reactance. All right, that's when resonance frequency occur. All right, and you can see this, there's a next question here. I think we should just quickly answer this question. It says at resonance, the phase angle in an AC circuit is 0. So at resonance, when the inductive reactance is equal to the capacitive reactance, there is no phase angle. So it would be 0 degrees. Are you getting me? So always know this. At resonance, XL is equal to XC, and also your impedance is equal to the resistance. Remember, as I said earlier, impedance is the resistance plus reactance, the reactance of the circuit. There are two different things here. Resistance, please take note. Resistance is this resistor. The reactance is what happens here. Are you getting me? The self-induced, is self-induction, that offers a resistance to the current, all right, or that builds up in the particular circuit. So we have this impedance is equal to resistance plus reactance. Okay, I'm just solving this video questions for you. Later on in the future, I will do a proper note explaining each term. Okay, but this, we are going through questions, and I'll be picking terms as we see them in the question. Okay, but I can't dive in there to explain it totally. So resonance, always remember that resonance frequency is it is when the inductive reactance is equal to what? The capacitive reactance, that's XL equal to XC. And also your impedance is equal to the resistance, and the phase angle in the AC circuit at resonance is what? 0 degrees. Remember that, all right? So we've answered this. So now let's do this calculation here. So from here, okay, now, so there's a formula. So there's a formula for what? Resonant frequency, and it's what? Fr is equal to 1 over 2 pi the square root of the inductance over and multiplied by what? The capacitance. All right. So this is the capacitor value, and this is an inductor. So this, we are to find the inductance. That's what, to find L. Okay, we are given what? F, the resonant frequency FR, okay, 200. We have C. We are told to use pi as what? 10. Okay, so let us now solve. So from here, here now you have to apply your knowledge of mathematics, which is change of subject or formula. Please, if you don't know that particular topic in maths, it's going to affect you in physics, also in chemistry. You must know that topic. If you hate maths, just make sure to pass well in your physics and chemistry, make sure you know the topic, change of subject of the formula. And I've done that in this particular channel. You can check that out in the DTW tutorial. So I've explained it, okay, in very well, thoroughly. I've explained that particular topic, so learn it. So now we have to do the make L the subject of what? Formula, because that's what we're looking for. So what do we do? Let's take this square root up here, bring F here. All right, so we have 2 pi FR, okay? So now to take off this square root, all right, to take off this square root, it means we have to square everything on our right-hand side. So we have here LC is equal to 1 over, this will be 2 square, all right, this will be pi square, and this will be FR what? Square. So now from L to stand alone, we divide both sides by C. So we have L is equal to 1 over 2 square, which is 4, and here we are told that pi square is 10, so just put times 10, and so let's just put times FR square, then times C. Okay, are you with me? Follow me closely. So from here, let me come up here. So we have L is equal to 1 over this 4 times this is 40, so 40 times, what is our FR? FR is 200 kilohertz. Okay, so 200 kilohertz. Let's quickly resolve this. 200 kilohertz means 200 times 10 raised to the power 3. Okay, so you must be able to, yeah, in your scientific notation, you must be able to know how to play around with it. All right, so this we have to square. Is that not it? And we can quickly reduce this. This is 200, so we can quickly, if we want to take off these 2 zeros, okay, it means we'll go 1, 2. So we add what? 2 to the power of what? 10. So we have 2 times 10 raised to the power what? 5. All right, all squared. So to square this now, it means this will give us what? 4. Okay, we square 2, 4, and this 2 would multiply this 5 here. So what do we have? We have 10 raised to the power of what? 10. All right, so here that would be 40 times what? 4 times 10 raised to the power of what? 10. Okay, that's value for FR. We've gotten this. Now C is not squared. We brought C down here. So, and C is what? 20 times 10 raised to the power minus 12. Are you seeing that? So we say times 20 times 10 raised to the power minus 12. All right. So from here, what do? We can just quickly multiply, right? So let's resolve these two first. Let's quickly play around these two. So we have L 40 times, that's why it's always good in Jamb. Please, when you're practicing, practice without your scientific calculator. All right, it's going to help you. Don't depend on your calculator when you are reading for your Jamb. All right, learn how to do this manually. So this times this will give us what? 80. Now to resolve this scientific notation here, This is 10 raised to power 10, and this is minus 10. You know, this is indices. So we have 10, then we have minus what 10. So it means we're going to reduce this. You know, 10 minus 10 from the power of 12, we're going to have what? A minus 12. Remember, minus 12 plus 10 will give us what? Sorry, a minus 2. All right. So this is a minus 2. That's 80 raised to power of what? 10 raised to power minus 2. So here we have 1 over 40 times. Now here we can now reduce this. If this is 10 raised to power minus 2, so it means we can move this 2 times to change it to standard form. So we have 1, 2. The power of, you know, when it is minus 2, okay, we move our decimal from our right to the left. So we have 1, 2. So this becomes 0.8. Are you seeing that? Okay, please, you have to be good in maths in this. I can't start explaining this, okay? So now we have 1 over 40 times what? 0.8. Here, you can quickly use, instead of you start doing all this, all right, you can quickly now use your normal calculator in the Jamb CBT interface. So 40 times 0.8 will give you what? 32. All right, so our inductance will be 1 over 32 Henry, okay? So the unit of inductance is what? In Henrys, okay? So and our right option here is option C. Can you see that? So this is how you break down. All right, try and learn how to walk around with scientific notation and standard form in maths. Also very critical in your physics and also in chemistry. Okay, try and learn this. So we've solved all this here. We've gotten this. The phase angle in an AC circuit is what? 0 degree. All right, so let's clear this. Let's go to the next slide. Okay, now the next question here says what? The current through a resistor in an AC circuit is given as 2 sine Wt. Remember, current in our is equal to what? IP, peak current sine Wt. This is what our angular what? Frequency, and T is what? Our time, and IP is the maximum what? Current, okay, or peak current, and I is the instantaneous what? Current, okay? So this is the formula. Remember these two formula, and V is equal to Vp sine Wt. Okay, these are the current and voltage formula to get in an AC circuit. These are the formulas you use. Okay, when you're told to find the current, you're told to find the voltage. This is the formulas you use. Okay, so remember these two formula. So here we're to apply. We're looking at currents. Okay, and it says the current through a resistor in an AC circuit is given as this. So we're looking at current. So this will be 2 sine Wt. So this 2 here is what? IP. All right, it says determine the DC equivalent of the current. The DC equivalent of the current is IRMS. Is the root mean square current. Okay, and remember that root mean square current is what? IP over the square root of 2. So this would be what? We're looking for IRMS, which is DC equivalent. So that would be what? IP, we are given as 2 over root 2. Remember, in surds, you can't leave, resolving surds, you can't leave it this way. You multiply both sides by what? The numerator and denominator by what? The square root of 2. Okay, so this would be 2 root 2, and multiplying two square roots will give us what? 2. So this 2 would cancel, and we're left with the square root of what? 2. That's root 2. So our answer is what? A. Square roots in ampere. That's I is current in ampere. So our answer here is what? C. Do you see that? How quickly we did that? Okay, so that's the answer for that. Now, on to our next question. Okay, it says, at what frequency would a capacitor of 2.5 microfarad used in a radio circuit have a reactance of this 250 ohms. Okay, reactance is measured in what? Ohms. So capacitor, so the capacitive reactance is this, XC is equal to what? 250 ohms. All right, and the capacitor itself is what? 2.5 microfarad. Now, in finding the formula for finding the capacitive reactance, Xc is equal to what? 1 over what? Wc, angular velocity. And remember that angular velocity is equal to what? 2 pi f. Okay, f is what? Frequency. So here we have 1 over what? 2 pi fc. Don't forget this formula. This is for formula for capacitive reactance. For inductive reactance, XL is equal to WC, which is also a small w omega w, okay, L, okay, so which will be 2 pi f what? L. Okay, don't forget these two formulas. Are you noting down the formulas? Okay, as you're watching this video, you can pause and write down the formulas. Okay, so here we are to use this formula here. So we have our XC, let me write down our values. Our XC as 250 ohms, and we have our C as what? 2.5 microfarad. Remember, microfarad is what? That is 2.5 times 10 raised to power minus 6 what? Farad. Okay, that's micro, that is minus what? 6. So let's impute it into our formula here. So we have 1 over 2. Are we giving the value? Okay, we're just to put pi like that. So 2 times pi. Our f, what is the frequency? Okay, we're looking for our frequency, right? Is that what at what frequency? We're looking for the frequency. So I think let's just quickly make our frequency subject of formula here. Okay, let me quickly erase this. Oh, sorry. Quickly erase this. So let's just quickly make f the subject formula here. So from here, if this is xc is equal to this, so it means take f up, bring xc down. Okay, please go and read up on change of subject formula. I can't start explaining it here. So 2 pi xcc. Okay, so from here we have 1 over 2 times pi times xc is what? 250. That's our capacitive reactance. Then C is what? Times, we have it here, 2.5 times 10 raised to the power minus 6. Okay, now we have to resolve this. Okay, so we can quickly just multiply all these values here. If we do 2 times 250 times 2.5. All right, you can use that calculator there now for, that's why they kept that simple calculator. Make use of it. Okay, so we can do 2 times this, and that will give us 1 over 1250 pi times 10 raised to the power minus 6. Okay, now in I hope I'm not mixing scientific notation and standard form. In scientific notation, that's 10 raised to the power minus 6. Okay, when you have, let us now split it. You know, this is 1 divided by this and this. So we have 1 over 1250 pi. Okay, still times 1 over 10 raised to the power minus 6. You know, this statement is still the same as this. Now, when you have 1 divided by a 10 negative 6, it gives you what? A positive power. Do you understand me? Remember your indices. Let me quickly explain this so you understand. Remember your indices. Anything raised to the negative power in indices is what? 1 divided by 10 raised to the power 6. Is that not it? So here, this statement means, let me write this. I have to manage my space. This statement here means 1 over 1 over 10 raised to the power 6. And which would come up? You know, you invert. When you have 1 divided by 1 over 10 raised to the power 6. To change the division sign to multiplication, it becomes 1 times, you have to invert your right hand this side. Okay, so it becomes times 10 over 6, 10 raised to the power 6. So which will give us what? 10 raised to the power 6. So this statement here is what? 10 raised to the power of positive or 6. So this, let me come up here. Okay, so this becomes what? F becomes 1, that's 10 raised to the power 6 over 10, 125 pi. Are you with me? Are you with me? So from here, also, okay, let me not break it down. Let us try to resolve this. Hold on. Oh, Jesus. Okay. Okay. So we have 1 over 1250 pi times 10 raised to the power 6. So now you can use your calculator to divide 1 over 1250. So what would that give us? That would give us what? 1 over 1250, that would give us what? A 0.008. All right? Over three, it's going to give you 3 zeros over pi. I've solved this. I don't want to start using calculator here. It's going to delay us further. All right, times 10 raised to the power 6. And you see this pi is going to be left under because it's still under. You have 1 divided by this. This will give you what? 0.008 over pi. So you need to know how to break down your calculations. In calculation, that's why maths is quite very involved. Break it down to simple terms so you can quickly resolve it. So from here, so this is 10 raised to the power 6, and this quickly you can, if you know this is in standard form, if you want to convert this to scientific notation quickly, okay, this would be taking your decimal point to, if you take it from the left to your right, it means to convert to scientific notation, the power will be in negative. So let's say we do 1, 2, 3, 4. So we have 8 times 10 raised to the power minus 4 times 10 raised to the power 6 over pi. So from here, we can easily resolve this power. So negative 4, this is times plus 6. That will give us what? 8 times 10 raised to the power a negative 2, right? Over pi. And what is this? Oh, sorry, it's not going to give us a negative 2, a positive 2. All right, negative 4 plus 6. Negative 4 plus 6 will give us what? A positive 2. And what is 8 times 10 raised to the power 2? That is 8 times 100. Is that not it? 10 raised to the power 2 is 100 over pi. So we have what? 800 over pi. All right, so this is our final answer. This is the frequency in what? Hertz. Okay, and the right option here is option A. All right, so I have to break it down for you to explain everything. That's why this is calculation. All right, so even if this video is taking time, just take your time to watch it to the end. All right, so this is how we resolve this. You can always replay. Okay, now let's clear this and see our next question here. This question says, when an alternating current given by this, remember as I said, I is equal to IP sine WT. So this is 10 sine in bracket 120 by T. Okay? So this is W and T. This here is what? IP. 10 is equal to IP. Okay, passes through a 12 ohm resistor. The power dissipated in the resistor is, now in AC circuits, the power is equal to I square root mean square, I square R times I square root mean square times what? Your resistance. That's the formula for power. Okay, so here we are giving IP, we have to find IRMS. Remember, IRMS, you need to know this formula. Root mean square is equal to IP over what? Root 2. Okay, you already know the value for IP, which is 10. So we're looking for our IRMS. So IRMS is equal to 10 over root 2. Okay, and remember that 1, always remember this too in AC circuit. 1 over root 2 is equal to what? 7.07. They won't tell you here, but you should know. 1 over root 2 is equal to 7.07. I think on the calculator, is there anything like square root? I've really forgotten. Okay, but just know this. Okay, so it means here we have 10 times what? 7.02. Okay, because this is 10 over 1 over root 2, which is the same as 10 times 1 over root 2, which is 10 times 7 point what? Okay? And sorry, not 7.02, I mean 0.702. I'm sorry, not 7.02, 0.70. Okay? So we have 0.707. All right? 0.707. That is 1 divided by root 2. Okay, please. 0.707, not 7. Okay, it can't be 7. This is 1 divided by root 2. It can't be 7. So 0.707. So this will be 10 times 0.707, and that will give us what? 7.07. So our value for the RMS is what? 7.07. So we can come here. P is equal to I square R. So that will be 7.07 squared times our resistance here of the resistor, okay, is what? Our value for the resistor is what? 12, all right? So 7.07 square, that you can use with your calculator. You have what? 49.2804, then times 12, and that will give us 599.81 watts. And you can approximate this to what? 600 watts. Okay, so this is our answer, and our option here is what? Option C. Power is measured in what? Watts. Okay, so this is the answer for this. So let's clear this and go to the next question. Wow, already getting exhausted. Okay, now this question says an AC circuit of EMF 12 volts has a resistor of resistance 8 ohms connected in series to an inductor of inductive reactance 16 ohms and a capacitor of capacitive reactance 10 ohms. The current flowing in the circuit is, okay, so an AC has an EMF, okay, our volts of what? 12 volts. It's connected in series. We have a resistor. Let's say we have the capacitor here, and we also have the inductor here. Okay, so resistor is what? 8. Our inductor is 16 ohms, the inductive reactance, and our capacitor is how many? Is what? 10 ohms. Okay, so we're told to find what? To find the what are we told to find? The current I. So to find the current I, we already have the EMF. So this EMF is Vrms. This is the effective value, the root mean squared value. So impedance, okay, remember as I told you, V is equal to IR. Impedance is what? Resistance plus what? Reactance. Impedance, okay, is what? R V RMS over I RMS. Okay, so we can find our RMS if we know our impedance. We already know our VRMS as what? 12. So we have to first find impedance. And this is an RLC circuit. Resistor, inductor, capacitor circuit. Okay, so impedance for this, the formula for impedance for this circuit is what? R square plus, in parentheses, XL minus XC all square. Okay, so here is XL, inductive reactance, and here is what? XC, capacitive reactance. Okay, so let's put in our value. Our R square is 8. Okay, that's 8 squared plus, in parentheses, this is 16. So we have 16 minus, this is 10 squared. So this will be 64 plus this minus this is 6. And 6 squared is what? 36. 10 minus 6, 16 minus 10 is 6. And 6 squared is what? 36, all square. When we add this will give us 100. And the square root of 100 will give us what? 10. So our impedance is what? 10 ohms. So from here, okay, we have 10 ohms equal to 12 volts over IRMS that we're looking for. So, change of subject of formula. So IRMS will be equal to 12 divided by 10, and that will give us 1.2. This is I ampere. Okay, so this is what our current flowing in the circuit, 1.2 ampere, and this is option B. Okay, so let's clear this now. To this question, it says in an AC circuit that contains only a capacitor, the voltage lag behind the current by 90 degrees. Okay, not 180. It's either by 90 degrees or pi over 2. Okay, degrees. Okay, so in case you don't see 90, if you see pi over 2, it's the same thing as what 90. Pi is what 180, and 180 divided by 2 is what 90. Okay, so this in a capacitive a circuit containing only a capacitor, voltage always lags behind what the current. Okay, and the phase angle it lags behind is what 90 degrees. But for an inductive, if it was an inductor, okay, that contains only an inductor, okay, it is not current that it is not voltage that lags, it is current that lags behind voltage. It's opposite. Okay, so always know that. For capacitor, voltage lags behind the current. For inductor, current lags behind the voltage. Now, look at this same question that has been twisted. It's the same thing but twisted again. And it's the same answer. All right, it says when an AC voltage is applied to a capacitor, no power is consumed because the current. Now, here, they says the voltage lags behind current. So it also, from this statement, it also means that current is leading the voltage. Are you getting me? This is just you understanding of your understanding of English, your comprehension of a statement that they can use to confuse you. Okay, if current is lagging behind, if voltage is lagging behind current, it means that the current is leading. So here it says because the current would leads by 90 degrees. So here our option is what? Option B. It leads the voltage by the same angle 90 degrees. Okay. Inductor, the current lags behind the voltage by the same 90 degrees. Are you getting me? For an inductor. All right. And here, if it was an inductor, if this was an inductor here, and they said because the maybe they put the voltage here, you say because the voltage does what? Leads. Okay, to be leads in inductor. Are you getting me? Don't be confused. If it was an inductor here, and they said voltage, the voltage leads because in an inductor, the current lags behind voltage. So voltage leads in an inductor. Why? In a capacitor, the voltage lags behind the current. The current leads in a capacitor. Are you seeing it? Capacitor, let me write it down so you know. You don't want to confuse it. Capacitor, uh, voltage lags, current leads. Are you seeing by what? 90 degrees. Okay, 90 degrees. While inductor, okay, current lags and voltage leads. Are you seeing that? By the same what? 90 degrees. You can note this, okay? In case there's any, quick questions like this that you can easily get. All right, so let's get on to the next one. Hold on 1 minute, please. Okay. All right. Now, this question says, what does the question say? It says, from the diagram above, the inductive reactance and the resistance R are respectively. So we have to find inductive reactance and we have to find resistance. Okay, two things we have to find. The inductive reactance of this inductor, this is the value of the inductor 0.1. Okay, so let us do this. So remember, inductive reactance formula, as I've said earlier, is XL is what? WL, which is also 2 pi F what? L. So we've been given our frequency as this, and we've been given our O point H as what? That's our inductor. L is the inductor, value for inductor, as 0.1. So we have 2. Were we told to put in pi or just leave out pi? Okay, let's put in pi times pi. F is what? 50 over pi. So that pi would cancel out 50 over pi. times 0.1. So this will cancel. We have 2 times, you can use that calculator for this. 2 times this is 100 times 0.1, you get 10. Inductive reactance, the unit is what? In ohms. So our first answer is 10 ohms. So you can see, easily just tick C. You don't even need to calculate again. Are you getting? You don't need to waste your time to calculate again. This is the right answer. So, but to get our resistance now, our resistance of the circuit, okay, so what do? We do what? R is equal to what? V over I, all right? And what is V? V is 75 over I is what? 1.5. And when you do that, you're going to get what? 50 ohms, all right? Do you see that? So that's the answer for this. Then let's quickly solve this. Let me clear here. So for this says from the diagram above, if the potential difference across the resistor, capacitor, and inductor are 80 volts, 110 volts, and 40 volts respectively, the effective potential difference is, so we're looking for the effective potential difference of this. This is 40, the VC is what? This, and VR, it should be VR, okay, because the resistor is 80 volts. Okay, so remember, as in an AC circuit, okay, we have VC RLC, V square RLC is equal to what? VL minus what? VC square plus VR square. Please don't just go and add, because I just saw in the past question that that's why, you don't just practice past question, okay, and follow the answer that you see there. No, that's why the CBT app is very important, because all the answers there are being solved and solutions proven. Okay, when I what I saw here, they just added 40 plus this plus, and the answer is here. 40 plus 80 is 120, and 120 plus 110 is 230. This, look at the answer. No, it is very, very wrong. In an AC circuit, VL, the voltage in the inductor and in the capacitor, they are out of phase, and they are out of phase by 180 degrees. Okay, this is VL and this is VC. They are out of phase by what? 180 degrees. In case you are asking an OBJ question, the voltage in a let's say you have like an RLC circuit, or even a LC circuit, okay? In an LC circuit, in an RLC circuit, the voltages are out of phase by 180 degrees, okay? So, and when you want to find the resultant voltage, it is VL minus VC. Are you getting me? So please, that's why you need this particular CBT app, all right, to help you. My battery is getting low. Let me charge. To help you out, okay, to help you out with the correct solution, because after you tick your answers, it will show you the correction. You will see it in the DTW tutorials Jamb CBT app that has been proven, okay? So please don't make mistake of adding. No, this is the right formula to use here. So we have this. So our total effective potential difference, let me come down, or let's write it here, please. So VL, what is VL? VL is what? That's 40 minus what? VC is what? 110 square plus what's VR? VR is what? 80 square. Okay, so here 40 minus this is what's 40 minus that's 70 square. Okay, minus 70 square plus 80 square. And minus 70 square is what? A positive, right? So we have, if you use your calculator, please, I use calculator for this. So you should you can use also that calculator, all right, and add, then try to resolve the square roots. Okay, so here we have this is V square RLC minus V. So let's just remove this minus because it's going to cancel out, plus 80 square. You know, to get just V alone, remove this square. It means we're going to square root this. So when you punch in your calculator, this square plus this square, then the square root of it is going to give us 106.3 V. Okay, you look for, use your calculator. I think there's square root in that calculator. Use your calculator on your Jamb, the Jamb interface to resolve this, and you get this. Okay, and the right option here is option D, not this. Don't make the mistake of adding. No, in an AC circuit, the VL and VC, they are out of phase. You can never add them. All right, so this is the right what option. Let's clear this and get on to the next one. Wow, I don't know how many hours this video is already going to. But we're going to do this. We'll finish it by God's grace. Okay. Now, hold on. Haven't I solved this? Haven't we solved this? Oh no, we've not solved it. It's also twisted again. The same thing but twisted again. You can see Jamb, the way they repeat their questions. Okay, so it says the current output form of an AC source is given as this. So remember, I is equal to IP sine WT. So this is what 10 sine WT. So where 10 is what IP. Okay, the DC equivalent, no, we've done this now. The DC equivalent of the current is what? Let's just still do it. So we have RMS, that's the RMS value. So IP over what? Root 2. Okay, so that will be what? 10. No, we've not done this. Okay, so that will be 10 over root 2. I remember 1 over root 2, I said is what? 10 times 0.707. So, and 10 times this will give us what? 7.07. And that will give us, we can approximate, and that will give us what? 7.1 ampere. All right, so our right option here is what? B. We haven't done this. So just, I think another question was asked. All right. Okay, we did this, but the option was in square root form. All right, not in the not in your normal numbers. Okay, it was in square root form. We've done this before, but the option, if you remember, we did sorts. Okay, on it. All right. So where our final answer became root 2. Okay, Abby, was it that it? What did our final answer become? Yeah, the square root of 2. Okay, so 10 times this is what? This. Am I correct? Okay, yeah, in that particular question, this wasn't 10, it was 2. If you remember, this was 2. Okay, this wasn't 10. So this is still the same way you solve it. Always remember this formula. It's very important. Okay, in your AC circuit today, it's always repeated. IRMS is always repeated. All right. So now let's get on to this. It says what? Let me clear this. It says when a certain AC supply is connected to a lamp, it lights with the same brightness as it does with a 12 VDC battery. The RMS value of the AC supply is, okay, when you have something like this, all right, say when a AC supply is connected to a lamp, it lights with the same brightness as it does with this. Okay, the RMS value of the AC supply is what? Also what? 12 VDC. You don't need to start going to use this formula. RMS equal to IP. That's when you are told to find the peak. Now, from this statement, it says, I always say the RMS is the effective value of a varying voltage or current. It is equivalent to a steady DC. Okay, so from here, this same 12V, we also brighten the same bulb with the same supply. Okay, when a certain AC supply is connected to a lamp, it lights with the same brightness as it does with a 12 VDC battery. So it means that this the source of this is using the RMS value of the effective value of this same one battery. So the same answer will be what? C. Are you getting my point? So here the RMS value is equal to that of what? D DC. So you have V RMS is equal to V DC here. So it says here, for example, a lamp connected to a 6 VRMS supply will shine with the same brightness when connected to a steady what? 6 VDC or supply. They say, however, the lamp will be dimmer if connected to a peak. That's why I said it is not, you don't go and start looking at how to get the peak. If connected to a peak, it will be dimmer. Okay? If connected to a 6 V peak supply, because the RMS of this is what? 4.2. If it's a peak, if you calculate the RMS, it will be lower, and which means this is a steady what? 4.2 VDC. Are you getting my point? So it's different. If this was say a peak, then the answer will be totally different. But it says what? The same brightness as a 12 VDC watt battery. So here in this statement, VRMS is equal to VDC, and which is also what? 12. All right, so you need to understand this. Now, the next question here says, in a tuned radio receiver, RLC series circuit for resonance, the inductive and capacitant and capacitive reactance XL respectively are related as, I've said this from the beginning, is what? Your inductive reactance is equal to what? Your capacitive what? Reactance. The option here is what? A. At resonance, XL is equal to XC, and also Z, in case Z, your impedance is equal to what? The resistance, not reactance. As I said earlier, your impedance is your resistance plus reactance. Reactance either in the inductor or the capacitor. Okay? So, but in resonance, this is equal to this, and Z is equal to what? R. All right, let's go to the next one. We're almost done. 15 questions. We're almost done. Okay? Okay. So for this, all right, for this, we have here, which of the following is the correct shape of the graph of capacitive reactance XC versus frequency F for a pure capacitor in an AC circuit? Now, for a pure capacitor in an AC circuit, the graph, remember your formula, XC is equal to what? 1 over WC. Is that not it? Huh? Look at it. The graph of capacitive reactance versus frequency, and this is equal to 1 over 2 pi what? FC. So it means we have XC here, 1 over 2 pi FC. So this is going to be what? They are going to be what? Varying. So the graph would be, the curve would be like this. But if it was XL, that's your capacitive inductive reactance. Remember that inductive reactance is what? WC, which is also 2 pi F, WL, which is also 2 pi FL. So it means that this what varies what? As what this means, sorry, well, let me explain again. What this statement means is, as this increases, okay? No. As this increases, as F increases here, X what? Decreases. Are you getting me? That's what this statement means. Okay? If we, let us, we're looking at the capacitive reactance versus the frequency. So let us bring XC is equal to 1 over F. No, we just bring out the 1 over F here. So as F increases, X will what? Decrease. All right? So it means our graph would be this way. For your XL, in case you are looking for XL, this is F, bring out F. As F increases, this also what? Increases. The graph will be like this. For this, directly what? Proportional. Are you getting here? This is what? Inversely proportional. So it's going to vary. So the correct option for this question here is option 1, D. Okay, it is what inversely proportional. While for XL is what directly proportional. This will carry L. Okay, I'm just explaining. As I said, I'll be explaining everything in the topic. All right, so this is the graph of your capacitive reactance versus frequency for a pure capacitor. Then in the case for your inductive reactance, okay, versus frequency for a pure inductor, the graph will be like this, directly proportional. All right, while for XC, the graph would be like this. So for this question, this is the what answer, D. Okay, following our formula here. All right, is this the last question? I hope this is the last question. Sorry I didn't number the questions. It takes a lot of work to prepare these slides, to sit down and look for the questions, solve, and then prepare the slides again. It takes a lot of work. So to even number it, I just left it that way. Okay, but I think this is the final question. Let us see. Okay, now, yeah, it says this from which of the following graphs shows the correct vector diagram for the circuit above? Yeah, I had to put this question so you understand what the vector diagram. Okay, so which of the following graph shows the vector diagram for this? And this circuit is what? This is a inductor, a resistor. So this is an LR circuit. Okay, so in an LR circuit, you have different diagrams. Okay, so you can see here, I've put two things that we need to know. So this is a diagram for an LR circuit. Okay, so for an LR circuit, we have our inductor as this. Okay, and the voltage in the inductor is this way, while the voltage in the resistor is this way. So it says the voltage drop across the inductive reactance, this is drawn ahead of the current as the current lags voltage by an angle of 90 degrees in a pure inductive circuit. Okay, so you can see this. All right, so here the current lags behind what? The voltage. Remember as I said it earlier on, current lags behind voltage. Okay, so voltage will be up here. That's why your VL will be up here and your VC will be down. All right, your VC will be down. And the VR is always here. All right, and the angle with which it lags is what? 90 degrees. Okay, so the correct diagram here is where we have VL. VR can never see in getting the vector diagram. VR can never be here. VR will always be here in the middle. All right. VL is upward in an inductive circuit. All right. VL is what? Upwards. Okay. Your voltage leads, as I said earlier on. In an inductive circuit, your voltage leads, your current what lags. So the leads means the arrow up means it is leading. Current with what lag. All right. What else? What else am I explaining here? Okay, so the right option here is this. So while in a capacitive distance, okay, is drawn the current leads by what? 90 degrees. In a capacitor, as I said earlier on, current leads by what? 90 degrees. So we now have our arrow down here. That's for a capacitor drawing. You see your VC here and your VR here. Okay? So this is for an inductor. In case you are asked for a capacitor, all right, the following graph, what is the correct vector diagram? All right, for a capacitor, it's going to be this way. VC will be here and VR will be here. All right? Okay. So I think that's it for this question. And let me see if there's another one more question here. I'm already quite exhausted. Well, let me just do this for you guys. And anyone sitting for the okay, that's the end. That's the end. This is the last question. Okay, so and anyone sitting for forthcoming Jamb exam, thank you for staying tuned till the end of this video. And please subscribe, like, and share this video with your friends, family, loved ones preparing for Jamb. Okay, and give this video a thumbs up. Please share, comment. Yeah, I forgot to also mention from the beginning, if you have any other topic you find difficult in math, in physics, or chemistry, mention it in the comment section below. All right, so thank you, and see you in our next video. Stay blessed. You are destined to win.